Question number 20 is more of a geometry question. Equilateral triangle inscribed inside of a circle, and try to figure out how much area is inside the circle but outside the triangle. The first way that came in mind to solve this question, I was thinking about it really just kind of takes a long time, and since we're trying to average about 2 minutes per question here, it definitely takes longer than that, which I guess can be okay because some of these questions take less than 2 minutes. But just from a test taking strategy, looking at my choices here, I think there's really one big hint in here. If you want to figure out how much area is inside of a circle but outside of the triangle, you're going to have to figure out the area of the circle and then subtract the area of the triangle. Now if you look at the choices, sure enough, these look like area of a circle, especially with the pi in there. So, and then these are all subtract. These must be the possible, or what they think are the likely area of the triangle. And the unique thing there is all of these are slightly different. So I think if you can actually just figure out the area of the triangle, that's going to be sufficient information for you to know which one of the choices to do. So let's go ahead and start off looking at it like that, and then we can look at more of the bigger picture. Okay, so here's my equilateral triangle inscribed inside of a circle. Again, we're trying to find all this area in here inside the circle but outside of the triangle. So another thing, equilateral triangle we know has all congruent sides, so I went ahead and marked them all as 3 in case I needed to know that. Also, since all the sides are the same length, all of the angles have to be the same, so each one would be 60. And there is a fancy formula, I don't remember exactly what it is, but you could look it up to find the area of an equilateral triangle, and you can just plug in the side length and it gives you the area. I don't think most people memorize that, so what I would do instead is I would say, well, area of a triangle is also 1/2 base times height. Okay, I can see the base length is 3. Now the height of the triangle, that's going to be this, the thing that is perpendicular. I don't know what that is right away, but I couldn't figure it out with the trigonometry SOHCAHTOA equation. So looking at either the left half or the right half of this, I'll use the left half, I can say from 60 degrees here. Okay, so from 60 degrees, I'd like to find the opposite length. That's going to be the height when I know the adjacent length. So if all of this is 3, only because this is an equilateral triangle do I know this is going to be cutting this in half and giving me 1.5 for each of these. And this works because it's a right triangle, so we can use right triangle trig. And again, the thing I'm going to be referring to is SOHCAHTOA here. From this angle, I want it opposite over adjacent, and only tangent allows me to achieve that. Tangent of 60 equals h over 1.5. So the height is 1.5, which I'm going to write as 3 over 2. because I noticed none of the answers were written as decimals. They had fractions in there, so I'm going to go ahead and change that to a fraction, times the tangent of 60. And it would also be helpful to know what the tangent of 60 is. So that is a lot of unit circle. And to know the quotient identity. If you know that sine at 60 degrees is square root of 3 over 2, and you know the cosine of 60 degrees is 1/2. Again, I know those values because of memorizing the unit circle. Any tangent value you can find by dividing those. Sine divided by cosine. So if you took the square root of 3 over 2 divided by 1/2, you end up getting square root of 3. Now, I'm able to skip a lot of that. I'm processing it in my head, but I'm not writing it down because I use those things so much in pre-calculus that, again, so tangent of 60 degrees, I just know what it is. I use it so often that I have it memorized. So you may not have that same advantage. So here's the height, and I need to finish plugging that in over here. So I had the 1/2. The base we knew was 3, and the height after that work is 3 over 2 square root of 3. So if I multiply all my numerators together, I get 9 square root of 3, and if I multiply my denominators together, I get 4. So I know this is the area of the triangle. Now again, that's not really what they wanted us to do, but there's only one choice that looks like it's set up that way. Choice A looks like it's trying to subtract 9 square root of 3 over 4. None of the other choices have that. So number 20 will end up being choice A for that reason. Now that's a little bit of an assumption, I guess. So if I back it up here just a bit, okay, that's as far as it'll let me go. If I write that down, the area of the triangle, we ended up with 9 square root of 3 over 4. Now to find the area of the circle, we really want to find the radius length, and the radius can be drawn in any direction, but I think this one's going to be the most useful. And only because this is an equilateral triangle can I assume that this 60 degrees is being split into 2 equal pieces. So again, if I use one of these smaller right triangles, this angle is 30, this length is 1.5, this is a right triangle, I can do that to end up finding this length using a different SOHCAHTOA equation. So this time I would do from 60 degrees, I know the adjacent side is 1.5, and I would like to find the hypotenuse. So not h as the height of the triangle as I had over here. So maybe I use a different variable just to not get that confused. And SOHCAHTOA tells me that if I want to pair up adjacent and hypotenuse, the only trig function that's going to do that is cosine, so I have to put cosine here. Okay, if I do a little cross multiply here, x is 1.5 over the cosine of 60 degrees, and the cosine of 60 degrees, if I apply the unit circle, kind of how I was doing over here, to know tangent I need to know sine and cosine and divide them. Just knowing cosine is a little bit easier. Cosine of 60 degrees is 1/2. So this is like 3 over 2 divided by 1 over 2. Change that to multiplying by the reciprocal, and this is 6 over 2, or 3. That is the radius length. It's the hypotenuse of this triangle, but also the radius length. And then so from area of a triangle formula, I can do pi r squared, and r is 3, so that would make this 9. Alright, and I'm not really sure where they're getting that piece here. Looks to me like the area of the circle should be 9 pi. So I must have some kind of mistake here. So let me look at this for just a moment before I give up. Alright, I'm going to give up on this one. I'm not seeing a mistake here. I'll have to look at it again later, I guess, but luckily I don't think going through all of this is really a good strategy. Anyway, as soon as we figured out the area of the triangle, and just based on the way the questions were set up, that was enough for me to determine that that has to be choice A, and that was the correct answer.